multiplication facts is going to help you in so many ways. And so it's important that we practice strategies to help them come to us quickly and naturally. Now, if I told you that if you know your 2s, 3s, 4s, 5s, and 10s, you could solve other facts, what would you say? Because it's true. So I've got this fact here, 8 times 6. This is a whole lot of drawing here. In fact, I did it before we even started the video because I didn't want to waste your time. We don't want to count all these. We don't want to spend the time doing this every single time when we want to show 8 groups of 6 or 6 groups of 8. So how could we use something we already know to find the product? So here's what I'm going to ask you to do. If you have counters or some grid paper, I want you to pause the video in a second and go ahead and draw all this out. Yep, I want you to take the time to do that. Then I'm going to ask you to break it into a part that you might know that would help you find the product easily. Now remember, I said there are facts like your 4s or your 5s or your 2s that might help you to do this. So try somewhere around there and then come back and let's compare notes. Okay, let's look at this model and let's see how we can use a fact that we know to find the product quickly. Now I like to think of my 5s because I've been counting by 5 since kindergarten. And I know that instead of 8 groups of 6, I could have 5 groups of 6, which is 30, because I know that quickly. So here are my groups of 6, 1, 2, 3, 4, 5. I'm going to go ahead and just show this with a different color. So if you have counters, you could separate it, or if you have grid paper, you could use a colored pencil, something like that. And we said that this was 30, because 5 times 6 is 30. Now, that wasn't my math problem though, right? We could think about this second part as another math fact. What is this other math fact? Well, I know that I had 8 groups, but I only found 5 groups. So how many groups of 6 are left? Right here, I see that this is 3 groups of 6, which I know to be 18. Okay, so how does this give me the product? Well, if I know 30 and 18, I can quickly add those together, and that's 48. And guess what? That's the answer. And it's super fast instead of trying to skip count or count all these dots and make an error. Instead, I can break it into little pieces that are going to help me make sense of the problem. You could also think about recording it this way. So I could say 8 times 6 means 8 groups of 6. But I could break it into the parts that I know. So in our model, we did 5 times 6, and we also did 3 times 6. And then I can solve those pieces, and now we would get 30 and 18, and we can add them, and we get 48. Now, here's my question to you. Is that the only way that you can break it apart? Absolutely not, because the great thing about mental math is you do what makes sense to you and what comes into your head first. Because some of us may think of 5, some of us may think of 4. Did anybody think that this could be a double? If you were, and I'm going to draw a lot on my model here, so bear with me, but let's say I were to break it up instead right here and make a group here and a group here. Like I said, lots of coloring, but that's okay. Because now I'm going to show it this way. So instead of 8 times 6 being 5 times 6 and 3 times 6, I could think about 8 times 6 as being 4 times 6 plus 4 times 6, which is basically saying double 24, which if I double 24, I get 48. Now there are even more ways, and I want to challenge you to try that out. But first, we're going to try another way of looking at this problem with our 9 facts. I told you we were going to try a different problem, and again, I changed my video so that you wouldn't have to see me draw all these because it's super time consuming and we don't want to do that. But we're using the visual as a way to help us to find familiar facts. And then I'm going to show you how we can use an easier visual so you're not having to draw all these little dots here. So this time I'm trying to show 9 times 7. That's 9 groups of 7, and wow, that's a lot of dots. I don't want to have to do that. So let's think about a fact that we know. We could use our 5s again, like we did previously, or we can think of something that's even closer, which is what I drew up here. I actually drew 10 groups of 7. Why do you think I drew 10 groups of 7? If you have some grid paper, I'd love for you to go ahead and draw your rectangle, which will be much faster than drawing dots, and show 10 times 7. And I'd love for you to think about how you might use that fact to find 9 times 7. Pause the video and try it out. Did you come up with something? Because here's what I'm thinking, and I'm wondering if you thought the same thing. If I know 10 times 7, which basically is pretty quick, count by 10 7 times, right? And when I do 10 times 7, I get 70. It's pretty quick. But that's not what I'm trying to find. I'm trying to find 9 times 7. So how can I use this to make sense of that? Well, if I know that 10 times 7 is the whole, and I'm only trying to find part of that, I can use the part-whole relationship of addition and subtraction to subtract a group of 7 to get my product. So if I were to subtract 7 from 70, that would be 63, which happens to be the product because I had 10 groups of 7 and I subtracted that extra group of 7 because we don't want it, we don't need it, to find 9 groups of 7. Now how does that look? Because in the last problem, we broke apart a fact that we know. And we said, okay, we're going to break it into parts and then we can add those parts together to get the product. But how when we're dealing with a different whole, how does this look? Exactly like how when you did addition and subtraction, you thought of the part whole. Your whole this time is 10 times 7, right? And you know that what you're trying to find is a part of it, which is 9 times 7, and that the part that you need to subtract and to get rid of so that you can find this product is 1 times 7. So if I think about this, and I know that this is 70, and I don't know this yet, this is my question mark, I can think about 70 minus this part, which is 7, which will give me the remaining part, which will be 63. So it's just like a number bond when we had whole, and you have the parts, each component, and in order to add, you add the parts to get the whole, but when you're subtracting, you have the whole, you take a part to get the other part. So we had to make a different whole, thinking about 10 groups of 7, and subtract that extra group in order to find the group we really want, 9 groups of 7. This takes a little bit of thinking about it, but then once you say, oh, okay, I'm really just saying one group more and then subtracting the extra. It's like doing compensation when you add and subtract. Same concept, and it goes much faster than counting or skip counting when you can just think about your tens and subtracting an extra group. Go ahead and try another example by trying 9 times 6 and see how that would look in your problem by doing it with a model and by showing it by using the part-whole relationship.